from this point, I will try to explain 5G system architecture end to end. And maybe some of you know me, and I'm Rahim Navaei, and this is my email address. And you also find me in LinkedIn. This is my LinkedIn ID. If you want to check my page, I always try to post, to create some posts related to 5G system architecture, 5G NR, 5G, en-gRAN, and 5G core. And you can check also my posts related to 5G. Okay, from this point, I think many of you have seen the 5G system architecture in some way, from LinkedIn, from YouTube, and from some documents from 3GPP specification, and also from some books. But here in this webinar, I will try to present the 5G system in a different way, but you will see how I present. But I hope you enjoy the way that I present the 5G system. First of all, I prepared a slide related to end-to-end architecture in 5G system.
Can you increase the volume? Your voice is not audible to guys.
Now it's okay?
Yes, voice is very low, they are saying.
Okay, if my voice, okay, yeah,
now it's okay.
if oh, okay. And just let me to check in the chat if my voice is okay. Please write. Okay, thank you.
Yes, okay.
Okay, from here, I will try to explain 5G system end-to-end architecture. But as you know, like the previous technologies, I mean 4G, 3G, 2G, we have two parts again, the access network and the core part. But why we are using the access network, you will see, because in the 5G, we are using both the access related to 3GPP and non-3GPP, and both of them will be connected to the 5G core. And we can have one core just can support both the technologies, I mean 3GPP and non-3GPP. Because of that, we are using 5G access network. Okay, so we've got 5G access network, and we will see why we are using again 5G access network. And also we've got 5G core, and finally we will have 5G 5G system. So 5G system means 5G access network plus 5G core. But I think you have seen 5G system contain en-gRAN plus 5G core. But here you can see rather than en-gRAN, we are using 5G access network. We can see later why we are using 5G access network. Okay, we've got also data network. It could be internet or IMS. But again, if you remember in the previous technology, we were using PDN, packet data network. But here we are using data network. Why we are not using packets before DN? I will explain the reason that we are using data network rather than packet data network in 5G system. And this is very important to know for what reason the UE is using 5G system, because UE, first of all, should register with the network. When UE register with the network, it will be possible for UE to get the services from the 5G system, okay? Because 5G system are going to offer or deliver different services to the devices inside the system. So first of all, UE can register with the network. When UE register with the network, it will be possible for UE to get the services from the system. And again, this is very important to know for what reason we are using 5G system. Okay, I register with the network, and after that, I want to send and receive the data, for example, from the internet, from the YouTube. Okay, I'm going to watch a live stream in YouTube. Yeah, 5G AN. Okay, some one written 5G access. Yeah, 5G access network. You will see the abbreviation. You is going to send and receive the data from internet, for example, YouTube. Okay. So for this case, for this reason, we have to establish a session between UE and the last gateway in the 5G system. But what is the name of the last gateway in the 5G system? The name of the last gateway we can say is UPF, user plane function. Okay, this is the last gateway that can connect you to the data network to send and receive the data. So first of all, okay, so after registration, a PDU session should be established between UE and data network. But if you remember again, in the 4G system, when UE is attaching to the EPS, EPS, Evolved Packet System, or Evolved Packet Core, you are attaching to the Evolved Packet Core, you will get also a default bearer. It means a PDN connection will be established when attaching is accepted by the network. But here in 5G, it is possible to register with the network without any PDM connection. Here, I mean without any session. So, but in the new release of 4G, now it's possible due to machine type communication. Now it's possible for the devices to attach to the network without PDM connection. It is very similar to 5G system now. Okay, so you should consider both of them. I mean, both in 4G and 5G, now it's possible to register with the network without any session, without any connection to the network. So it's possible. But in the first release of 4G, I mean LTE release 8, it was not possible. When UE is attaching to the network, the network will give the UE a default bearer. I mean, a PDM connection is established by the network in 4G system. Now, there is the same scenario both in 5G and 4G system. So the reason UE is using the 5G system, okay, just to get a PDU session to send and receive the data. Now we have PDU session, okay? But if you remember, in 4G, we were using and we are using packet data network, but here we are using data network. Why? We don't have P before data network, because in 5G, we are going to deliver different services to the UE, to the devices, okay? And all of the services that we are going to deliver the users, just they are not related to IP, internet protocol. They are not related to IP packets, okay? IP just is one of the services we can deliver to the 5G devices. But except IP, we can have Ethernet. You can see just this is animated. You can see rather than IP, okay, we can have also Ethernet. What does it mean? Our 5G system now can act as a layer 2 network, okay? So can send and receive the data is coming from the UE, and just in the when we are using layer 2 network, it means we are using some Ethernet frame to send and receive the data. So it means when we are using Ethernet for PDU, we can have Ethernet PDU session. Now it's possible to send and receive Ethernet frame through our 5G system. Again, we can use also unstructured data. It means we can use non-IP session. Okay, so because of that, we are not using P before DN, data network. So you can see we can have IP session, we can have Ethernet session, and we can have unstructured session. But now in the new release of 4G, you can see, you can check, we've got also non-IP, non-IP EPS better. So it's possible in 4G again. So again, they are very similar to each other. So three types of session we have here, but also in new release of 4G, we can have three types of session again, IP, Ethernet, and non-IP. So just the term is different. In 4G, we are using non-IP, and in 5G, we are using unstructured. So it's very important now. We've I think we got the point why we are using data network rather than packet data network, and why we are using PDU before session, why we are not using just session, because PDU is going to be IP or Ethernet or unstructured. So again, this is very important to know. When the session is IP, there is a network function within the 5G code that is responsible to deliver the IP address, and the IP address will be also, I mean, IPv4 and IPv6. Again, when we are using Ethernet PDU session, who is responsible to give the UE the IP address? Again, IPv4 and IPv6. So there should be an application server or a DHC server outside of our 5G system. Now it's responsible to give or allocate the IP address to the UE. So first of all, we can say UE can be connected to the, I mean, data network through 5G system, and it can get by some protocol the IP address from the data network or DHCP server outside of the 5G system when Ethernet session is used. When we are using unstructured PDU session, again, we need an IP address which will be used by the last gateway user playing function. But there is a mistake here. You can see here, you will see UFP. This is not correct, and it should be corrected. UPF, user playing function. What does it mean? For unstructured and for non-IP PDU session, again, we need an IP address for that UE, but this IP will not be given, I mean, to the device. This IP will be allocated to the UPF or last gateway by one specific network function within the 5G core, but this IP will be used for send and receive the data from the last gateway to the data network, because we need to create a connection, an IP connection, a private IP connection, or we can use as a VPN, for example, between the last gateway and the data network. And for this connection, we need IP. But this IP will not be allocated to the device, just will be used here, because we are going to deliver from this point, I mean the UPF to the 5G device, non-IP packet. Is not IP packet. And we do not need any IP address, I mean the source and the destination IP address for this data pipe. So to send and receive the data from the UE and to the data network, we need a data pipe. We need a logical connection, and the name of this data pipe is protocol data unit session or PDU session. And three different types of PDU session we can have: IP PDU session, Ethernet PDU session, and unstructured PDU session. And as I told you, again, in new release of 4G, we've got also IP, Ethernet, and non-IP. And how this type will be clear for the network, for the 5G system, from where 5G system know which type of PDU session should be allocated to the device. when device is registered with the network, the device can request PDU session establishment. This request can be sent from the 5G device to the 5G network, I mean the
Could you
5G
please
core.
loudly? People are saying your voice is not audible.
Now it's okay?
Yes, yes, this is okay actually.
Okay, just okay, no problem. Uh, just yeah, from this point, just I want to say from where the 5G system knows which type of PDU session should be allocated to the UE. As I told you, first of all, UE can register with the network. After registration, UE can request PDU session establishment. Okay, a PDU session should be in place, should be established between the UE and the UPF. And the type of PDU session, IP, Ethernet, or unstructured, as an information element within the PDU session establishment, which is a NAS message, a layer 3 message, will be sent through the 5G access network to the 5G core. And there is a network function within the 5G core, which is called SMF, we will see later. And by getting the request, this network function will try to the session that you requested, IP, Ethernet, or unstructured. Okay. Let me explain more about the 5G access network. If you remember, I told you 5G, why we are using 5G access network. Some of you, again, you have seen en-gRAN, next generation radio access network. Okay, but now we are using 5G access network. For what reason, for what purpose we are using 5G access network? We will see here. 5G access network can be divided to the 3GP access network and to non-3GP access network. So because of that, we are using 5G access network. So if you remember, in 4G, we are using 3GP access, okay, and we can connect through 3GP access to the EPC, Evolved Packet Core. But if the UE, okay, UE may work both for 3G and non-3G, but if you want to switch to non-3G, for example, okay, UE can work simultaneously for 3G and non-3G, because if you remember, we can have LTE Wi-Fi aggregation. We can aggregate LTE and Wi-Fi just to increase the throughput. It's possible. But just consider a situation, UE can switch from 3GP access in 4G to non-3GP access. If you switch to non-3GP access, first of all, UE should be authorized and should be registered with the network. But there is, I mean here, evolved packet core is not be used as a core to register or I mean to authenticate or to authorize the 4G device. There are, for example, some other network function, for example, AAA and evolved PDG, okay, for user plan and for control plan, they are responsible to accept the 4G device to send and receive the data from non-3GPP. So in 4G network, there are two separated, I mean, parts. One of the part is used to accept the U in 3GP access, and one of the part is used to accept U in the non-3GPP. Okay, but now there is a possibility in 5G, just we can say a same core network will be used both for 3GP access and non-3GP access. So it means UE can connect through 3GPP and non-3GPP to a same 5G core. Again, we can find a network function within the 5G core can take the responsibility both for 3GPP and non-3GPP access. It's possible now in 5G. So because of that, we are using 5G access network because it is not related just to 3GPP access. It is related, I mean, to 3GPP and non-3GPP. But for non-3GPP access, we can have both trusted and untrusted non-3GPP access. For example, untrusted non-3GPP access, we can say through an access point. For example, WLAN, wireless local area network access network. It's possible, okay, to connect to the 5G core. But again, there should be some network function after this access point just to create a connection which should be secure to send and receive the data. Again, in non-3GPP access network, we can have TNAN, trusted non-3GPP access network. Again, WLAN we can use to be trusted. Okay. And one of the important thing you can see here, we've got also W5G AN, wireline 5G access network. Again, this access network could be considered as a non-3GPP access. Okay. So there is a possibility here now to use some 5G devices, and these 5G devices can be connected to the 5G core through W5G access network. So this is possible now. So you can see here, we can have 3GPP and non-3GPP access. And in this example, in this slide, I will try to use 3GPP access, but I think we don't have enough time to explain non-3GPP. Maybe in future, I can provide you some other slides related to non-3GPP, and I will explain more for non-3GPP, trusted, non-trusted, for wireline. Again, for wireline 5G access network, it should be trusted and non-trusted. And now in this webinar, I think we don't have enough time to cover all the slides. So let me to prepare some slides in the next webinar. So from here, from this point, I will try to explain 3GPP access. And you will see here, we can consider 5G access network as a 3GPP. Okay, you will see here, we will have 3GPP access network here. If we consider 3GPP access network, we can consider en-gRAN. 3GPP access network can be called again as an en-gRAN, next generation radio access network. Okay, from this point, we can use en-gRAN rather than 5G access network. And within the en-gRAN, we can have the base stations. Okay, so we can have the base station within the en-gRAN. These base stations can have some features, or they can be capable to be connected to the 5G core. So if you find any base station within the en-gRAN, it means they can connect it to the 5G core. So one of the base station we can have in en-gRAN is 5G base station. But what is the name of base station? Is g-NB. Okay, this is specified by 3GPP. So g-NB is the name of 5G base station. Also, we can have 4G base station. So if we want to use 4G base station within the en-gRAN, it means again 4G base station wants to connect to 5G core. And how it's possible? Here we have to add some capabilities to the 4G base station. It should be enhanced. It should be upgraded. Okay. For what reason? Because we want to connect the 4G base station to the 5G core. So the name of 4G base station can be changed. Again, 3GPP introduced en-gNB. We can say next generation GNB. So we can have two types of base station: 5G base station GNB and 4G base station as the en-gNB. And each of them, okay, each of them can prepare some resources to the 5G device through physical channels. Okay, so between, I mean, the UE and the 5G and 4G base station across the air interface, we can have physical channels. So actual transmission will be happening, I mean, in physical channel. Through physical channel, it will be possible to send and receive the data. For example, one of the physical channel for data to send and receive, we can say in downlink direction, we are using PDSCH, physical downlink shared channel, same as the physical channel that we are using in 4G, and PUSCH, physical uplink shared channel, again, the same physical channel that we are using in 4G, okay? And in 5G, I mean, in en-gRAN, we can deploy our 5G and 4G base station in different way. So here we have deployment scenario in en-gRAN. We can deploy our 5G base station or 4G base station as a standalone node. It means they do not need any help from other base station. They can connect to the 5G core separately in SA. So we can also deploy our base station in non-standalone way. What does it mean? It means for example, our base station cannot prepare the device the enough resources. So for example, UE is going to send and receive some data from the data network, and to receive the data from the data network, from the YouTube, for example, it needs throughput more than, for example, 10 gigabit per second. And from this point, the 5G device is connected to a SA node, for example, one of the base station. So it means from this point, these bases cannot prepare the throughput that UE needs to receive the data from the internet. And from this point, the base station can send a request to another base station to add this base station, to tell this base station, I need you to prepare extra resources, more resources for the 5G device, because I need your help, and we can work together to prepare the resources, I mean the physical channels, for example, and to send the data that UE is going to receive, and we can prepare and we can provide the throughput that UE again needs to receive the data. So from this point, we can say another base station can be added to our base station, and non-standalone solution concept now is coming. Okay, so we have two solutions for deployments: SA and NSA, non-standalone and standalone and non-standalone. And we will see later and how we can use NSA. So if we've got base stations within the en-gRAN, they can be connected to each other through an interface. The name of this interface is XN. If you remember again, in EUTRAN, the 3GP part of EPS, we are using X2 interface. So here, if two base stations are going to be connected to each other, we can use XN. And from here, you can see we have two lines, solid and dotted lines. Both user plane and control plane will be exchanged between two base stations. Now we can go to see some network function within the 5G core. The first network function we can see in the 5G core is called AMF, Access and Mobility Management Function. Now this node is responsible both for access and also for mobility. Okay. And if you is going to register with the network, which network function within the 5G core is responsible for registration, AMF, Access and Mobility Management Function, is responsible to register the UE. We have also another network function which can work with AMF to authenticate the 5G device, authentication server function. And again, we've got UDM, Unified Data Management, a database of user profiles. Okay, we can have the profiles of the user within the 5G system in UDM. So here we can say AMF with the help of AUSF and UDM can register, can accept the registration request from the UE. You know, first of all, UE should send registration request to the network. And this registration request will be received by AMF. And how it's possible to send this message through NAS, non-access stratum, a layer 3 message. Through NAS, the registration request will be sent to the AMF. And AMF, once gets, the registration request, it can work with AUSF and UDM to authenticate the UE. Again, if you know, both UE and the network can authenticate each other. If you remember in the first, if you remember, if some of you are working with 2G, okay, now there is a possibility in 2G, I will tell you. Just we can say network can authenticate the UE in 2G. But now again, there is a possibility in 2G, in the new release of 2G, there is a possibility both the 2G device and the 2G system, both of them can authenticate each other. But in the first release of 2G, there was not possibility for 2G device to authenticate the 2G system. Just 2G system can authenticate the UE. But here in 4G, 3G, in 5G, now there is possibility, a mutual authentication. Both of, 5G, both of the 5G core and the UE can authenticate each other. So we can say 3 network functions within the 5G core are responsible to authenticate the UE: AMF, AUSF, and UDM. And from here, I want to show you some terminology in 5G system. But again, just I forgot to tell you, now we are using network function virtualization concept, NFV. And our network function within the 5G core are virtualized. It means we are using VNF, virtualized network function. And each of the network functions that you see here, they are virtualized network function, VNF. And also, we are using the SDN concept, same as NFV we are using for transport. And with the help of SDN and also NFV, now there is a possibility to create some slices in our 5G system. Without virtualization, NFV concept and SDN, there is no possibility to create slices within the 5G system. So we have to use NFV and SDN. And with the help of NFV and SDN, now we can easily create logical networks or multiple logical networks which can be considered as a slice on the top of our physical infrastructure, I mean, physical infrastructure. But there is a new concept in 5G core when we are using virtualized network function. You can see here on the top of AMF, you can see this one, and AUSF and UDM. You will see they are connected. I mean, AUSF, AMF, and UDM, they are connected through a bus. The term that you are using in computer science. And the name of the interface above the AMF that is connected to the bus is SBI, Service-Based Interface. And it's based on API, Application Program Interface. That's the thing that I think you're familiar, that you have seen in the web client and web server. A web client and web server, when they want to communicate to each other, they are using API. Okay, so we are using this concept in 5G core. It means AMF, AUSF, and UDM, they can connect to each other through SBI, service-based interface. So a new concept you can consider in 5G core as a SBA, service-based architecture. It means the network function, the virtualized network function within the 5G core, they can connect to each other through a bus, through a service-based interface with the help of API. It means if AMF is sending a request to the AUSF and AUSF is going to respond to the AMF, they can use API call. I can write here. So using API call, the network function within the 5G core can communicate to each other. But you can see there is a network function which is called NRF, network repository function. If we want to complete, I mean, service-based architecture, we have to implement NRF, a new repository function. If you remember, UDM is a network function, can maintain the profile of the users, the devices. NRF is a network function within the 5G core, like UDM is a database, can maintain the profile of the network functions within the 5G core. So it is very important to implement this repository function in the 5G core. Why? Because if you remember, UE is going to send a registration request to the 5G core, and AMF will be responsible for this case, to take the responsibility for registration for that device. If you remember again, first of all, AMF needs to authenticate the UE and needs to communicate with AUSF. And how it's possible? Because AMF doesn't know which AUSF should use to communicate, to authenticate the UE. AMF can send a discovery message to the NRF. Okay, I want to find an appropriate AUSF to authenticate the UE. The request will be sent by AMF to the NRF through SBI interface through the bus using HTTP2 protocol. If you remember, in web client and web server, we are using HTTP version 1 and also version 2. Now the version 2 is used in service-based architecture. Just we are using one protocol to send and receive the data, I mean the signaling info between the network functions using HTTP2. So the request will be sent by AMF to the NRF, and NRF will send back the info that AMF requires. For example, the info related to some AUSFs. Maybe NRF will send the AMF multiple AUSFs. Again, there will be a configuration, I think, in AMF. With the help of this configuration, AMF can select one of the AUSF and can send the request using HTTP protocol, HTTP2 protocol to the AUSF. So it will be possible. So if we have implemented, I mean, NRF within the 5G core, now it's possible for all the network function to discover a network function that they are to send a request to it. So it's possible with the help of NRF. Now from this point, you will see AMF is connected to the 5G base station through N2 interface. This is dotted line. It means signaling info will be exchanged between two nodes. And en-gAP protocol will use to send and receive the signaling info through N2 interface, both by 5G base station and AMF. Again, also we can have N2 interface between AMF and 4G base station, en-g. Just again, there is mistake here. I should correct the mistake. This is not gNB, this is en-gNB. I mean en-gNB, because this is a 4G base station. Just it should be corrected. en-gNB. And we've got en-gNB, and en-gNB should be upgraded, should be enhanced to work within the en-gNB RAN to be connected to the 5G code. So the name is changed from en-gNB to en-gNB. Okay. So from here, from this point, we want to see some identification that can be maintained by you, the device. One of the identity is SUPI. But SUPI is very similar to en-gNB that you're familiar in previous technology, 4G, 2G, 3G. But if you remember, in 2G, 3G, 4G, if you is going to send an attach request, initial attach request, you has to, for example, to send en-gNB through across, I mean, the air interface to the MME as a network function in EPS. But here, I mean, 5G, now there is a possibility to do not send the SUPI to the network. Rather than the SUPI, the device can send SUKI, the concealed one. Okay. So again, so your identity will be safe because you're not going to send the SUPI through air interface to the gNB and then from gNB to the AMF. So the concealed one, because I mean, the device can hide the identity and then send to the network. And we are using PAY. This is very similar to IMEI, permanent equipment identity. We are using 5G GUTI. And if you remember, in 4G, we were using EPS GUTI. Why we are using both of them, 5G GUTI and EPS GUTI? Because maybe this UE is coming from EPS. It's changing the system from EPS to the 5G system. And if UE is going to send the registration request to the 5G system, UE can use the 4G GUTI and can map it to the 5G, for example, GUTI, and send to the 5GS, 5G system. And also UE also can be configured for a slice selection. So we can also maintain network slice selection assistant information. It is a collection of single network slice selection assistant information. For example, a device can be connected to a data network for enhanced mobile broadband. For example, again, can be connected to data network, can be used for massive IoT, and can be connected to a data network which is responsible for ultra reliable low latency communication for this device. But again, we can see later, we can have multiple slices just related to enhanced mobile broadband. 100,000 slices, for example, related to just enhanced mobile broadband. It's possible. There is a possibility in 5G, but it is trade-off. You should think about that. How many slices you have to create in 5G system. Okay, if you remember, to send and receive the data from UE to the data network, we need to establish a PDU session. And this PDU session will be placed between the UE and the last gateway, UPF. From this one, you can see here from UPF to the data network, we've got N6 interface, and you will see also PSA for this UPF. What does it mean? Because if UE is moving around the network, we want to have one of the UPF as an anchor. And this UPF is connected to data network, can be considered as an anchor for this device, for the PDU session of this device. Because of that, we are using PDU session anchor UPF. If we are going to establish a PDU session, some other network function we have to implement in 5G core, or we have to use them. If a request is sent by UE to the 5G core, first of all, AMF will receive the request. Which request? PDU session establishment request, which is a NAS session management request. AMF is access and mobility management function, and this network function is responsible to handle the NAS messages related to mobility management. So we can have two types of NAS messages: mobility management and session management. For PDU session establishment, which is a NAS message again related to PDU session, AMF is not responsible to handle this message. Which network function within the 5G core is responsible to handle this message? SMF, session management function, is responsible to create a PDU session, for example, IP session, and is responsible to allocate an IP address to the UE when receive the request from the UE. So AMF will act as a proxy for this NAS session management request. It means it will get this message and will send to the SMF again through the bus, okay, using HTTP2 protocol. But before to sending this message to SMF, an appropriate, SMF should be selected by the AMF. And how it's possible? Again, with the help of NRF, AMF can discover, and NRF can send back the info that AMF
requested multiple session management functions, and again AMF can select one of them and can send the request to the SMF. You will see here PCF, policy control function. Okay, so we need some policy both for access and for session. If UE is going to be accepted for registration requests, some policy related to access and mobility should be sent to the UE and should be maintained, should be saved in AMF. And how it's possible? AMF can communicate directly to the PCF, can get the info related to access and mobility, and then can accept, okay, because AMF first of all authenticated the UE, and also from here AMF can get some info related to access and mobility, and also AMF can interact again with the UDM, okay, to run some procedures, and finally AMF can accept the registration request, and some policy related to access and mobility that AMF got from the PCF can be sent to the UE. But for PDU session establishment, again, we need some policy related to session. Again, SMF should interact with a PCF, and PCF will send back the info that SMF requested. And session management function then gets some info related to policy, and also SMF can interact, can communicate, with UDM to get the profiles of the UE, and then can communicate to the PCF. Finally, we can say SMF can communicate to the UPF, to different UPF to create the PDU sessions. And also SMF can send some info related to PDU session to the gNB and also to the device. And it means the info for PDU session will be distributed by session management function to different nodes. To the UPF, to the 5G base station, and to the 5G device. You will see here also NEF, network exposure function. What does it mean, NEF? What does it mean? Because we can say here, our 5G system got some capabilities. These capabilities, okay, we are going to expose to the third party outside of the 5G system, for example. And who is responsible to expose these capabilities? Network exposure function can expose our capabilities. There are some different examples. Now we don't have enough time. Maybe later we can focus on specific, just on NEF, network exposure function, and to explain how it's possible for the network function within the 5G core, that they have some capabilities to send these capabilities to outside of the 5G system with the help of NEF. Then you can see here, within the data network, we can have application function. This is APF1, and this is AF1 and AF2, application function 1 and application function 2. Okay, but some of these application functions can be trusted and some of them cannot be trusted. Some of them can be located in the trusted domain of the 5G system, and some of them, they are not located in our trusted domain. I'm going to give you an example, a specific example. From here you can see if the application function is trusted or is located in our trusted domain, can communicate with PCF directly through N7 interface. I can give you an example. If you are going to establish, if you're going to establish PDU session related to, I mean, voice over NR. Okay. Yeah. First of all, you can create the PDU session, but I should show you some of the definition related to quality of service flow. If you are going to create some quality of service flow related to voice over NR, a network function within the IMF as a proxy call session control function, as an application function, should communicate to the PCF to send some info to the PCF, and PCF can send this info to the session management function. So they can communicate to each other through N7 interface. But for some of the, I mean, application function, they are not located in our trusted domain. If they are going to communicate or to send and receive some data within the 5G core or 5G system, they have to, first of all, they have to send the data to the NEF. NEF can act here as a proxy, should authenticate, should authorize this application function. And then it can send the data to the right network function within the 5G core. And again, in the new release of, I mean, 4G from release 12 onward, okay, we are using ESCF. Someone asked me, okay, yeah, again, exactly, NEF is similar to ESCF in 4G, yes. Service capability exposure function, you know, when we are going to, when we are adding some capabilities related to massive, not massive, machine type communication, enhanced machine type communication in 4G. Now we can add ESCF to the 4G system. And again, if you remember, we can have EPS bearer in 4G system, I mean, for IP, for Ethernet, and for non-IP. And we can create a EPS bearer related to non-IP, because we can use our IoT devices, Internet of Things devices in our 4G system, and we want to send some packets, okay? Just we are not going to increase the size of the packet. If we remove, for example, the source and the destination IP address, we can decrease the size, okay? So from this point, we need to send and receive some data can be considered as a non-IP data. So we can also create a session in 4G system, like in 4G, 5G, related to non-IP. If you remember, in 5G system, we are using unstructured PDU session, but in 4G, we are using non-IP. So the application function, for example, some application function within the data network, they are responsible to send and receive some data to IoT devices, but they want to send non-IP data, for example. They can send the data in 4G system to the ESCF, and ESCF then can communicate to the network function within the EPS, and finally can send the data to the UE, okay? So NEF is very similar to the ESCF in 4G. Okay, so now we can say why we are showing, I mean, AF1 and AF2, because some of the important info should be sent through, I mean, by the application functions to our 5G system. For example, which node is responsible, for example, to get this info? But many of the nodes, I mean, network function within the 5G can receive the data. But one of the network function within the 5G core that can get this info is PCF. If we want to, for example, to create a PDU session and to create some quality of service within the PDU session, we want to change, for example, dynamically some info related to the session and quality of service. These application function can interact with our 5G system and finally to the PCF directly or through network exposure function, for example, and can send some important info related to the PCF. And then when SMF communicate to the PCF to get the policy related to the session, PCF will send the data related to the session, the policy, PCC rules to the SMF, and SMF can send this data to the multiple user plane functions. But from this point, from here, we can say in the data path of the UE, from the UE, I mean, to the data network, we can have multiple user plane functions. You can see here, SMF can communicate here from this example to two, I mean, UPFs. One of the UPF, you remember, we called PSA, PDU session anchor UPF. And one of the, I mean, the UPF can call intermediate UPF. Why? We are using two types of UPF. For example, for this example, our UE is connected to the 5G basis station, and we are not allowed, for example, to connect our 5G basis station directly, I mean, to the data network with the help of, I mean, intermediate UPF. Now it's possible to create a data path, okay? So we will have intermediate UPF and PSA UPF, but we've got here an interface which is called N9 between two UPFs. And we also have N3 interface between our 5G basis station, 4G basis station, N3. Now, if we are going to send and receive the data, UE, first of all, for example, in uplink direction, UE can send the data through air interface with the help of physical channels and data radio bearer to the 5G basis station, and then 5G basis station can send the data through a GPRS tunnel, entry GPRS tunnel to the UPF, and also between two UPF we can use also GPRS tunnel. I mean, the things that you remember that we are using in 2G, 3G, 4G. Now we are using also, I mean, in 5G system. So now we've got all the interfaces. I mean, the air interface, 5G NR-UU interface, N3 interface, and N9 interface. And we also created our PDU session. Just remember, this PDU session can be related, I mean, to the IP, Ethernet, and unstructured. From here, we can consider as an IP session. SMF, session management function, with the help of PCF, UDM, okay, can send the info related to the session. For example, call of service profiles, call of service roles, packet detection roles, okay. This info should be sent to the UPF, to the, I mean, 5G basis station, and finally to the device. And we can say all the info related to the session will be distributed by the SMF to the nodes within the 5G system. So I can give you an example. For example, we are going to send and receive the data related to our VoNR, voice over new radio. We created our PDU session. This PDU session, it means we got an IP address, and this IP address will be used for our device to send and receive to the IMS for signaling point of view, okay? Because if UE is going to request, I mean, or to create a pipe for voice over NR, it has to create a quality of service flow. For this case, a signaling info, SIP, session information protocol, should be sent to the proxy call session control function within the IMS. Okay, and then how it's possible? It means we have to create a quality of service flow within the PDU session. And we can see here, for this quality of service, we are using an identity, an identifier. We can give an identity to this quality of service flow. For example, QFI1, QS flow identifier. And we can have multiple quality of service flow within the PDU session. If you refer to the 3GP specification, I mean 38.413 and 38133, you can find the quality of service flow identifier from 0 to 63, 64 quality of service flow. Okay, you can see. Sorry, just wait a second, I disconnected. Okay. And we can also have another quality of service flow. If you remember, to create a voice over NR, we have to send and receive some signal info related to VONR, okay? So we can, first of all, we can create a QoS flow related to the SIP, Session Information Protocol. And also, when signaling exchange between the UE and the IMS, another pipe, another quality of service flow can be created for that device. Here you can see QFI2. Like 4G, if you remember, we have default EPS bearer and we have dedicated EPS bearer within the PDN connection. If you know, in 4G, first we can create a PDN connection, okay? But if you remember, but during attach procedure, both PDN connection and also attach procedure can happen simultaneously. It's possible. It means when UE attach to network, UE can get also a PDN connection. But this PDN connection, within the PDN connection, we can have a default EPS bearer. Now, someone asked me, my voice is not okay. If my voice is okay, please write some thing in chat message. Okay, now it's okay. Okay, so from here we can see we have two quality of service flow within the PDU session. One of the quality of service flow can be considered as a default QoS flow, and one of the QoS flow can be considered as a dedicated QoS flow. Okay, but for both of them, we can allocate an identity QFI1 for default and QFI2 for dedicated. But we have to separate, we have to differentiate these two quality of service flows. But for this example, we are using two quality of service flows. But maybe for some devices, we can create, for example, more than 5 quality of service flows possible. But this is an example. In this example, we are creating just 2 quality of service flows, okay, 1 and 2. And to differentiate these 2 quality of service flow, I mean to differentiate the IP flow that are coming from the data network, that they are we want to send these IP flows to the device, we have to put to different quality of service flow. And how it's possible? Again, UPF, by getting some rules from the SMF, can differentiate the IP flows that are coming from a data network or different data network, and it can send the IP flows in a different quality of service flow. So for each quality of service flow, we can have 5 QI. I mean 5G, quality of service identifier. Okay, and you can see 5QI5. This is a value that is used for default for IMS signaling. This is same also in 5G. We are using 5QI5. If you remember, we are using QCI. Okay, in 4G. Now we are using 5QI. So QCI is using for EPS, but now 5QI is using for quality of service flow. And you can see here 5QI1. Again, this is a value that is used for a dedicated quality service flow, for example, for voice over NR, for conversational cases. Okay. But each of these value, we can refer to a table. We can see which parameters we can find for these two specific values. Okay. Again, you can refer to the spec. I mean, to 3GP specification. I mean, here, I can write here. (23.501). Okay, you can refer to this specification and you can find a table related to 5QI and you will find the parameters. We can differentiate, I mean, the IP flows that they are coming from multiple data network with the help of quality of service flow. Okay, so granularity of the quality of service flow will be done with the help of QoS flow. If you remember, this granularity in 4G will be, I mean, in 4G with the help, in 4G with the help of EPS, we can differentiate the quality of service flow. Okay, so here the granularity in 5G we can implement. Okay, I mean, to differentiate the quality of service flow with the help of 5QI and also QoS flow. So there is a table here I will show you. I don't know it's clear for you. Can you see the table under the previous session? Just, I mean, there is an icon, stop sharing. Now it's possible. Now it's possible for you to see the table. Can you see the table under the previous session? Okay, I hide. Now it's possible. Thank you. Now it's okay. Okay, thank you. Okay, so we can consider all services as a guaranteed bitrate, non-guaranteed bitrate. The two types, you have seen in 4G, but we also have another resource type in 5G, which is called delay critical guaranteed bitrate. Okay, these are the resource type that we are using in 5G. Okay, for example, 5QA1, this is used for GBR guaranteed bitrate. If you remember voice over NR, this is guaranteed bitrate service, so it's clear. And 5 is considered as a non-GBR, a signaling that is exchanged between you and the IMS. Okay, this is non-guaranteed bitrate, so there is no, we don't need to guarantee, guarantee to the rate between UE and the IMS. And you can see another parameter, packet error rate. Okay, also the priority we can consider for each 5QI and some other parameters. And finally, you can see for what purpose we are using. This is an example. We are using 5QI, for example, 1, 5, and 86. For example, 1 is used for conversational voice, and
5 is used for IMS signaling, and finally 86 is used for V2X, I mean message. So now we want to check how it's possible to carry our court of service flow, and how it's possible to send and receive the court of service flow. Okay, so first of all, you should know, for example, just you can consider here, you can remove one of the UPF, I mean intermediate UPF. Just you can consider a PSA UPF. We've got one UPF, and our 5G base station is connected to the UPF through N3 interface. So between I mean 5G base station and the UPF, we got N3 interface. An N3 tunnel should be created for a specific PDU session. It means each PDU session can have just one N3 GPRS tunnel. And for this tunnel, we need tunnel endpoint identity for uplink, both for uplink and downlink. And how it's possible, again, when UE, I mean during PDU session establishment, this info tunnel ID identifier in uplink and downlink direction will be exchanged and will be received by, I mean 5G base station and also the UPF. Because if 5G base station is going to send the data to the data network, it needs uplink tunnel ID. If UPF is going to send the data to the UE in downlink direction, it needs a downlink tunnel ID. Okay, so this tunnel ID should be received by UPF and the 5G base station. The uplink should be received by 5G base station, and the downlink tunnel ID should be received by the UPF. So we can say we've got here two quality of service flows. These two quality of service flows can be exchanged using N3, I mean GPRS tunnel. But when they are receiving, I mean the quality of service flow will be received by base station and should be sent to the UE. Between the 5G base station and the UE in the air interface, we've got data radio bearer. But here, just I'm using two data radio bearer, but there's a possibility, okay, to map, I mean, two quality of service flow to just one data radio bearer. Again, it depends to the configuration in the GMB. Okay, so and also if you remember, session management function will send some info related to session, for example QoS profile. The QoS profile for each QoS flow will be sent by the SMF to the GMB, and we also have some configuration related to the session in 5G base station, and 5G base station with the help of this info can decide, okay, how to map the quality of service flow that are coming from N3 interface to the data radio bearer, to the one or to the multiple. Okay, so for this example, each quality of service flow will be mapped to a specific, I mean, DRB. So we have two DRB. One of the DRB will be used for the default one. We can consider this DRB as a default DRB, data radio bearer, and the another one will be used for the dedicated quality of service flow. So we can consider this DRB as a dedicated DRB. So again, if you refer, I mean, to the 3GPP specification 38.1, I mean 331, okay, you can see the DRB numbers from 0 to 31, 33, 32, okay, DRB number you can see. But again, when you see again exactly, when you go in very detailed in 3GPP specification 38.331, again you will see just 29 of these DRBs can be used, okay, in the air interface. So we can have multiple quality of service flows, and we can have multiple data radio bearer in the air interface for a PDO session, and how the mapping will be done for the QoS flow to the data radio bearer. It depends to the configuration of the 5G basis session and the session info that received from the session management function. Okay, now just I think just I can ask the administrator how much time we have, okay, to continue, and I can continue some other slides. Are you here?
Yes, yes, sir, I'm here.
And
Hello.
yeah, how much time I have?
Almost I finished.
Okay, just I've got some other slides, but maybe just I try
We
to
can we
explain. I mean,
can we
5G.
can we can do for the next webinar because almost 2.5 hours already passed. We can keep this for the next month webinar. This topic.
Okay, yeah, I've got just as I told you, I tried to explain a 5G system in end-to-end architecture. Okay, so
Yeah.
I hope you enjoy my way for presentation. If you remember with my post in LinkedIn, always I'm going to create a post for 5G system, I mean, as a big picture. Okay, now we can consider this slide as a big picture, and I hope I gave you some info related to 5G system. Okay, but maybe we will have some extra time in the next webinar to, I mean, to present some other slides related to 5G system. But I prepare some slides related to dual connectivity and also slicing. Now we don't have enough time. Sorry for that.
Yes.
Okay, thank
So that,
you all of you again to
guys,
participate in the webinar.
also we present 4 courses, like 2 courses will be presented by Mr. Rahim, already share in the chat message, and also we will email you regarding the 5G in our system and the 5G in our architecture. And one courses I present that is for the ORAN in the depth, almost 8-hour course, and another one is that 5G Ericsson optimization. So if you are interested, you can go through that, and you can ping us in the LinkedIn to ask about the Q&A. Okay, so that's the things.
Just one more thing. I want to say something to all of you that you are participating in the webinar. Just always I create some posts related to 5G. But if you see my last post in LinkedIn, it's related to, I mean, 5G NR related somehow to the physical layer. But this is very, uh, just we can say there are many people in the LinkedIn, just they can see, okay, they can see the post, and just they do not focus on the post, okay. But I think this is related to those people, but they don't care. But I want you, okay, if you are interested to some posts related to physical layer or to 5G system end-to-end architecture, to refer my post in LinkedIn. If you have any question again, you can send me your question through direct, and I also gave you my email address. Okay, also you can your question through my email address, and I will be sure I will respond to your question. Okay, thank you.